This is Erica Hathaway, and I'm going to be doing Physics C, Chapter 9, number 69. And so to save time, I'm going to skip over reading the problem. Please read this problem on your own. It is in the textbook. Duh. Okay, so the first thing we're going to do is we want to draw ourselves a picture. So I drew ourselves a picture. We have the chains. This is the original chain before it moves, and then this is going to be an original chain after it moves. We know that the chain is length L, and then we know it drops the distance x. So the new length, it's going to be floating kind of above the table. It's going to be L minus x. We also know that the mass of the chain is going to be M, big capital M. We can tell from that information that the mass of one of these chains, just one, is going to be M divided by L. So if we want the group of chains down here, how much that weighed, it's going to be M over L times x. The reason why it's times x is because it's going to be the same amount of chains dropped here. Right? Alright, so the first thing we're going to do is decide what we want to find out from this problem. The problem says we want to solve its force exerted by the table on the chain after the distance x. That is the key word, after distance x. And it also tells us to assume that all the chains here are going to be at rest as soon as it reaches the table. So we're going to think, what kind of forces could be affecting this chain, right, from the table? Well, the first force is going to be our normal force, because this is going to weigh down on a table, and then the table is going to push ourselves back up. So we know that normal force is one of the forces. The second force, we're just going to call it force F. It's the force as the chain is going down and the table is kind of like pushing it up. Alright, so let's solve for the easy force first. We know that forces equal mass times acceleration. So our normal force is also going to equal mass times acceleration. And we know that the mass of this, which is going to get pushed up, is M over L times change in x, because that's going to be our total mass of the chains that's actually on the table. And then times acceleration, which is gravity, which if we're going to rearrange it, it's going to become mgx over L. Yay, simple. Alright, so our other force F is going to also equal ma. But we also know from this chapter that the force can equal change in momentum at an instant point, which is going to equal dp over dt. We remember that p, which is momentum, is going to equal mass times volume, right? So it's going to be dmv over dt. From calculus, we remember the chain rule, which is going to make it equal to v dm dt plus m dv dt. If you don't know the chain rule, please go back to learning calculus before you do physics. Alright, so we know that dv dt is going to be 0 because there's no acceleration at that instant point. And then we know that dm dt exists because the energy is not being, is not constant mass. Why? Because at any given point, there's more chains falling and landing on top of the table. Alright, so we also know that dm dt equals m over L times change in x, right? That's exactly what I just said, because it's going to be the mass of one of the chains times the amount of change that there is going to be at an instant point. So if we simplify that, it's going to equal force equals v over dm dt, which we're going to plug in what we have here for dm. So it's going to equal force equals volume times m over L dx times 1 over dt. Remember that dx over dt, this equals volume. So if we simplify that more, it's going to equal v squared over m over L. Since this is our actual force, but we put our first force in terms of mgx and L, we want to change velocity if possible to some other thing. So from our kinematics, we know that vf squared equals vi squared plus 2a change in x, which if we plug everything in, it's going to be v squared equals 2a change in x, which is going to be 2gx, because gravity is our acceleration and our change in x is x, labeled x. So we know that force equals 2gx m over L. Ta-da! So now it's all in terms of gx, m, and L. Exactly what we need. So our total force is going to be Fn plus F which equals mgx over L plus 2 mgx over L, which is going to be 3 mgx over L. And this is our force that is being applied on the chain by the table. Congrats, guys! We solved it. Have a good day. And good luck finishing the rest of your physics homework.